we're going to want to do a couple of things with now non-right angle triangles. So we cannot use the opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent anymore. We are using non-right. So don't know if you'll be able to spell or pronounce this properly, but to label our angles now, let's see if we can spell it properly. Ready? To label, and we call this angle here, we're going to call this A. Capital A. And this angle here, we will call capital B. And to go with the flow, we will call this angle capital F. No, it's C. And so the sides that are opposite this angle, again, not opposite, adjacent, hypotenuse, whatever, ready? See if you can spell this one again. This will be little a. So opposite capital A, little a. Opposite capital B, little b. And opposite capital C, little c. Now, I hope to promise you that when we do these questions, you will not actually have to label your triangle A, B, C. The reasons that we've got these labels here is so we can refer to the rule and you can see how the rules work. Without ruining your surprise, from the poster over here, these are the rules that we're going to go through. And we're going to start with the one at the bottom. So if you want, on your formula, on your one page, which will probably end up being double, if you want to put examples for each one. So the first rule that we are going to look at is how to work out the area of a non-right angle triangle, right? Half AB sine C. And you might be going, well, hang on, I know how to work out. I have a formula for area of a triangle, yeah? What's the formula for area of a normal triangle? Half base times height. The problem with that formula of a half base times height, so there it's non-right angle, right? You have your base, but you will need your vertical height. Now, we're going to have the situation where you're not going to be given the vertical height. So then we can use this formula, okay? What do all these A, B, C's and stuff mean? Well, let's have a look. When we've got A and B, so we're looking at A, B, and then we've got the angle C. Where's your angle C? Right there in the middle. So again, friends, fans out there when I go. Anybody? Okay, we're talking about we need just two lengths and we need this angle in the middle. Now, does it matter if it's these two lengths and that angle or this two and that? No, I don't care about A, B, C, whatever, as long as it's just two lengths, angle in the middle. Does that make sense? So let's do a little bit of an example. As I said, we're going to have three different formulas that we're going to mess around with, and at the moment, the thing that we know why we're going to look at our area formula, because it says area, okay? As you can see, we have definitely got our two lengths and the angle in the middle, agreed? So I am not going to bother labeling anything. I'm just going to go straight into area equals a half AB sine C, and I know that the A and the B are the two lengths surrounding the angle. So what are the two lengths surrounding the angle? 11 and 15. I don't care if you say 11 times 15 or 15 times 11 because it's the same. And sine of the angle in the middle. And it's off to your calculator and we're done. That is it. Okay, so we've got that pretty simple, straightforward. Where is the degree of difficulty? I don't think it's anywhere. If I asked you to find the area of this triangle here, what would you say to me? Exactly, you cannot, because you've got two lengths and you've got an angle, but that angle has to be here. And because we do not have that angle and we haven't got enough information, you would have to say, sorry, can't find the area of that triangle, not enough info. Huzzah? Huzzah. Once again, we're given a non-right angle triangle, but this time it's asking you to find a length and they've given you the area. So what's a good mathematician going to do? And that's all of you. Excellent. You will write the formula. So area is a half AB sine C. Sometimes when I'm fooling around with this, because we know that capital A also refers to an angle, so sometimes I actually write area instead of just A. But look, it's straight underneath, so I'm happy with that. And then what do? We've got our formula. Eugene, what would you do? Fill it, sub it in. So A is for area. We know our area. So we replace it 136.3. It says equals, I put equals, a half. Right, we've got AB. What are my two lengths? 13 and X. And we're making sure that we write nicely. So our X's look like an X and our timeses look like times. They don't look like the same thing. And then we've got sine. Do I know our angle? Absolutely, 57. You guys have got brilliant algebra skills. You know, how do I get rid of all the timesies? Dividesies, right? You've got times here, you've got times there. So my next line will just be, it's the other side. And we're dividing by all of that, the half times the 13 times the sine 57 and to the calculator. That's it. So can someone work that out, please? Okay, so the very last type of example. So we've said we've got all the information, got the two lengths, got the angle. Just slap it straight into the formula. Bang. Second type of question, you've been given the area, but you're missing a length. Put it in, rearrange. The last type, yes, we've got the area. So once again, we are going to be wonderful mathematicians and say area is a half AB sine C. And Alan, you want to kick it off?
It's just like theta equals.
Oh, theta equals. I'm not a fan of going straight to theta equals. We've got our formula. We should sub. So do we know our area? Absolutely. Have we got our two lengths? Yep, and we've checked that the two lengths are in fact surrounding the angle that we want. If theta was here, then we would say, sorry, no can do. So a half times 24 times 30 times sine, and there's our theta. Oui? Now this is a nice one, and I know you could just go a half times 24 is 12, but normally what we want to do is just use our calculator once, because they might be yucky answers later on when we're doing questions. So I'm going to rearrange this beautifully. When I say I mean you, to get sine theta by itself. So anyone want to have a go? What would sine theta, how would I get sine theta by itself? Yeah, Naila? Is that, oh, no, yep.
You can divide.
Wait.
You can divide the 24 and 30 and put it on the other side. It's like, yeah.
So when you say that, you mean we're dividing 231 by the, yeah. So 231.4, so we're getting rid of all of this times. And we know to get rid of the times, we just divide. We will go to the calculator, but that will give me sine theta. I don't want sine theta, I just want theta. So how do I get rid of the sine? Inverse sine, again, loving the language that you guys are using. So sine to the minus 1, I'm going to be a little bit cheeky and not rewrite everything and just go, yeah. No. Why has that gone funny? Oh well, we still live and learn. So we'd go into number 1. I can't even get my entry button up. Come on, people. Come on. Anyway, nope. Half of it's, yep, view calc screen, small. Now we're, okay. So we'd go into normal calculator mode. I am recording, right? The reason that I'd like you to type this in first. So 231 So we'll go fraction button 231 point, someone will call it out to me, 4 over 0.5 times 24 times 30. Okay, oops. When you want to go inverse sine or inverse cosine, if this value here, if it's bigger than 1, or if it is more than -1, you will get an error. You'll get syntax can't do it. So it's nice to see at this point, have you made a little bit of a whoopsie somewhere? If you accidentally put 1 over the other, if you left out the 0.5, if you just typed the wrong number, so you accidentally typed 4 instead of 24, it's a good gap stopper. Does that make sense? And now I just go shift sign of my answer. So my answer key is above here. So shift answer and then press enter. And mine is weird because I'm in radians. So I've looked at it. I've gone, oh, yep. That doesn't seem like a sensible answer. So I'm going to go shift, setup, scroll down, change it to degrees. And then I just press enter and I'll get my answer, which now seems reasonable. Oui? Yep. So we get 40. So this will now be 40 degrees. So all we can do, people, is have one of those questions. It's either going to be finding the area, which is a straight substitution. So question 1 is just straight, slap it in. Don't worry about 2. Question 3, same deal. So are you going to do every single question from question 1 and question 3? Be sensible. Right? What's going on with question 4? Which length do you have to use? Right, because they're 13 and 7 because they surround the angle. What about this? Here's my 2 lengths. I don't have the angle. Are you going to tell me you can't do it? Right, you've got 2 other angles, so you should be able to find this angle, 180 degrees in a triangle, and away you go. So not too bad. So if you are close, or once you've finished your assignment, hit this. The assignment we are going to mark in class on Monday. Yep, we're going to switch. So someone else is going to be reading your work. So make sure that it's neat. I will choose who reads it. Yep. All right. So the rest of the lesson, that's half an hour. Excuse me. So half an hour by Monday's lesson, and the end. You've got end of this. You've got homework. You will make sure the assignment is done, and you will make sure that this area is done. Okay? This exercise. Thank you. Goodbye.